Hello, this is tdouce with the National Robotics Challenge. I'm joined today. We're going to be talking a little bit about our 1 pound plastic combat robot. I'm joined today with Peter Leeper and Sheppard. They're with Great Oaks. And Peter, we've worked together on and off for a number of years. He reached out to us last year after the last NRC and said, boy, if you guys would add a 1 pound combat class for plastic. So we've been doing that in our local schools. We've had a lot of success with it. I know I can get some more teams for you. So we talked it over with our advisory committee. We said, why not? Let's put it together. So I've never built a 1 pound myself. So I asked Peter and Zach if they'd be willing to hop on a video here and kind of talk about how they create a combat robot so small and how they get that figured out and what their process is. Maybe help some of our other teams that are new to combat. Seems like this is a great entry point for that competition. So Peter, turn it over to you.
All right, very good. Thanks for having us, and we're happy to share what we got cooking here. When COVID hit and everybody shut down, it really had a big impact on our BattleBots program. We've been building the 15-pound robots for good 15 years now. But we haven't had a competition for a couple of years, and our talent graduated, and so we were starting over. 15-pound robots are hard, especially with kids that are still figuring out how to run a cordless drill. Wanted a way to train ninth graders and build up from there. So the 1 pound idea was born from that, and got a hold of a few schools that we work with and pitched the idea to them, pitched the idea to some local industry, got some money going. And Zach put a lot of time into developing like a basic robot idea that would work, and train some people and train some kids. Had a competition last year. Everyone loved it. And we wanted to grow it. And so we did another training. We now have 7 schools in our league. We have a competition in January. There should be 24 robots there. So it is catching on. Kids are loving it. You get quick cycle time. You know, your idea doesn't work. Well, tomorrow you have a new robot. You just print it overnight. And so it helps speeds that up. And then we're looking to add 3-pound metal and 15-pound. It's just scaling up. And once you know the components. So that's kind of the driving force behind it. I want to show you what Zach put together at this was now 2 years ago, and at the time, so this is a horizontal spinner robot, the chassis for that. You'll see a lot of standoffs inside, so we were thinking we would need a lot of contact places to make connections. Master my camera here.
Yeah, that's good.
Wheel guards and whatnot. And discovered, well, you really didn't need all those. You could save some weight, other areas. This would be an example of a weapon. Now, the key here, no matter what your weapon is in a 1-pound robot, is you want to have, what would you call that, Zach? You've got direct drive. Okay, yeah, direct drive. So in the 15 pounds, we're almost always some sort of transmission, some timing pulleys or V-belts.
Sure.
But it just takes up too much space and too much weight in the 1-pound category. So
gotcha. That certainly simplifies the construction of it, doesn't it?
For sure.
Wow.
And there's, if I can pop that out of there, you'll notice that there are some cavities there, and there are some threaded holes. And in this particular example, I don't think this weapon was made for that motor, but you can see there's some small holes there for the screws to go in. And right now it's just a flat bore, but if you notice the motor itself, it has some geometry there that you could model around and help prevent slip.
Nice.
This is the direction we're going now. Okay. Yeah, this would be like this year's iteration of what kids are trying to do.
No, very
And
cool.
I don't think that one's for this motor either, is it, Zach? No.
Those are the older.
Right. So since I mentioned motors, this came from a vendor called Palm Beach Bots. Yeah, and so there are our number one supplier for things in this category.
It's Flash Hobby.
Flash Hobby. So,
Oh, nice.
okay. So we bought a bunch of those, and the kids are designing all sorts of weapons to go with it, even a drum style. Same, you have direct drive, and then you've got to support the weapon on the other end.
There's a laundry.
All right, this would be an early iteration of trying to use a transmission. This actually would work. We just don't get a lot of energy from the weapon on this one, but it just, this robot ran in our earlier in this year. We had a competition in October. It ran there, so I mean, it wasn't very devastating because really this main weapon system, but just shows that's the stuff you got to have. And
yeah. So you're using a gear motor then on the drive wheels, it looks like?
yes, I'll hold that up for you. Okay, this company is called FingerTech. They're out of Canada.
Oh yeah, we've heard of them. Yeah.
And well, they have a US supplier in Florida. So Palm Beach Robots. And I think this one is you can see the gear ratio on there.
Nice.
I think this one would be a little bit slow, but that depends on what else you got going on your robot.
Sure.
Foam wheels.
Very good. Okay.
This is all comes from FingerTech. These are FingerTech wheels. FingerTech sells hubs to go with it.
Oh, nice.
Show you that. That blue snap hub.
Oh,
That'd be a twist.
yeah, that's very nice.
Well, there's snaps and twist. And twist is the more recent version. But
Gotcha. So it just kind of locks onto the axle then, or the shaft, with just like a direct pressure onto the shaft.
Yeah.
No keyway or anything in there.
That's right. That's right.
Makes it nice if you get some damage on the wheel, you can swap it out real quick then.
Yeah, it isn't hard to swap those out. To control the motors, this is another FingerTech product. Here's your electronic speed control.
Oh wow, that's tiny.
Tiny ESC.
Huh.
These are pretty common in small combat robotics, and we're pretty happy with them. Still looking for other alternatives to save costs, but these we've been very pleased with.
Now, what are those? You have an idea what those cost a piece for those little speed controls?
I'd have to double check, but
okay,
say $20 for one of them.
Pretty affordable then, really.
Right, it's not 100.
Yeah.
Do you remember what the FingerTech sell for, the speed controls?
$25.
Yeah, I was guessing 20 to 25, more than what we think it should. Let's put it
No,
that way.
right. Yeah, we're in education, right?
Well, show you these hubs. Okay, so it would slip on the motor there, and it does have a flat. The shaft does. So it's got a set screw. Sorry, folks.
Oh, okay, nice.
Set screw. So that'll press up against the flat, and then you would put the foam wheel on, and then you would press this in.
Gotcha.
You just work it on there.
Yeah.
And then twist in the hub.
And those little teeth that stick out, grip into that foam. Looks like their hub has like pieces that stick out. Very nice.
So yeah, we're still playing with different sizes. They come in various thicknesses as well. So we don't know what the magic combination is, but kids have figured out.
Part of the fun, right?
Part of the chase.
Very cool. Yeah.
All right. If schools have done BattleBots before, they may be familiar with these receivers. If they have a Spectrum system, these orange style, the DSM style. that's a nice and expensive way to utilize what you already have. But if you're buying new, I would not get Spectrum. It's just not necessary. There's at the Palm Beach site and on the FingerTech site, there's radio receiver combinations with a different protocol. So they're not going to interact with
Sure.
Spectrum. But what, $50?
Yeah.
Oh yeah.
Comes with a receiver and it comes pre-programmed. And there is a programming cable that comes with it. So you can change the programming, but it comes set up for the left stick controlling throttle or weapon motor. And the right stick is already mixed so that it would control the channels, elevator and aileron, so that when you press the stick forward, then both wheels would go forward.
Oh, that's nice. Wow. Yeah, and you don't really need a real expensive radio. I mean, a lot of schools think, oh, I got to buy this, $300 or $400 radio. It's not necessary for this level of combat for sure.
I'd say if you started with absolutely nothing, $300, you'd have an entire robot, and most of that's you'd be using over and over again.
Yeah, could really use like your speed controls. You could reuse, right? Then what do you guys use them for batteries?
Small as you can find.
Wow.
So this one's a 2-cell. So
Okay.
this one's a lipo. And we will go with lipos until we find a better option, but they're light. And 2 cells will give you what you need. But we're going to even mess with a 3-cell as well to get some extra boost in the weapon. But this is just 300 milliamp hours. It's pretty small. And it's not even $10. I mean, these are very inexpensive.
Yeah.
Just a little bigger.
We have
It looks just like kind of what we have for our drones. We use for our drone competition. We have very similar batteries.
All right, so this is a Hobby King battery. Again, 2 cells, but it'll last longer. I think 300 will do the job. 300 milliamp hours. This is a little bit larger. You can see the 0.45, so
Sure.
450 milliamp hours.
Yeah, so really you're able to reuse your radio, you're able to reuse your receiver, you're able to reuse the battery as long as you don't have a really violent encounter. Probably can most of the time reuse the motors. I suppose your wheels probably get tore up a little bit.
A little bit. So far, the number one component has been a bent shaft.
Yeah.
So as we
Understandable.
learn better ways of supporting those and keep them out of harm's way, then but you can buy just the gearbox replacement and swap it out with the motor.
No, that's nice.
All right, so if this is your brushless motor for the weapon, then this is what you're going to want for the, it's Flash Hobby. This is from Palm Beach bots as well. And I'll flip this around so you can see inside the package. Hopefully it's a 20 amp speed control. It's got the BL Health firmware on it, and this only goes in one direction. You can get them there that are bi-directional. For your weapon, you want one. That way the stick all the way back is off.
Gotcha.
Is 100%. You don't want kids to be having a weapon that goes both ways. I suppose there could be some advantage, but we're talking about 9th graders and 10th graders in our world, and we want to keep it as easy as we can to get them going. So we definitely recommend a single direction speed control.
Sure. And if the motor's going the wrong direction, you just reverse the 2 leads and it spins the other way, right?
That's easy. But to have them be going one way and then another based on the like you can have brushless drive, which we do for the larger robots, but we don't want that. We're not doing brushless drive for the 1-pounders.
Now, do you have any problem with? Oh yeah, sure. Do you have any problem with the brushless getting damage, be it on the weapon, or are they pretty robust?
Only $12.
So no, but we're not afraid of that. It's only $12.
Oh yeah, true. Right. That makes it all very affordable. But most of your components are really 3D printed. The body's all 3D printed then, for the most part.
It is. The only thing that is not 3D printed are the fasteners. So you may have seen
Sure.
the Vex 1-inch standoffs.
Mm-hmm.
But the purpose of that is to receive the screw. We're not using those for armor, so that's part of the
Right.
requirements when we're inspecting the robots. So here's a
Very
couple
nice.
more components to pick up from
yeah.
Tech. These little mini switches, get
Yes.
lots of them.
Yeah. Yeah.
If you can find a cheaper alternative, please tell us.
Yeah.
And these terminal blocks we found to be very helpful. And this
Oh,
allows
nice.
students to make connections all in one place. Color coded, reds go together and blacks go together.
Oh, very cool. So there are two. There are a red block and a black block of those.
Yes.
Then okay, nice. And those just glue down or stick down, or just kind of hang out.
They just hang there, yeah.
Gotcha. Gotcha.
We have the
That's
student
nice though.
design a place for this to just get a press fit inside.
Okay.
So where's that? There, you can see that little rectangle.
Oh yeah. Okay. Okay. Then
Press
just
down.
an Allen key lets you has just emergency shut off. Then
So when
now you guys have do they have to be on the top or the bottom or the back, or do you guys have any rules on that when you guys have your competition?
Easily accessible.
that's right.
It's unwritten actually, but it should be written top or side, a safe way.
Yeah.
So this is an example here where you can see the hole.
Oh yeah.
Right down in here where
Yeah.
we have access to it. We asked for a light to be visible, so we know that there's power to the system. And most of the time, the receiver has light on these orange ones,
Mm-hmm.
and the FingerTech speed controls have lights on them.
Okay.
We haven't, at least in these, we haven't had to wire up an additional light. The larger ones we do, but I think it's wise to know if something has power or not, especially if it's
Sure.
it still has power. We need to know. So
That's very cool.
any more here? Okay.
That's all the parts that
Yeah.
we have.
All right. So we've had 2 competitions so far, and the robots are getting better and better. You think 3D printed, how strong is it really? And so there is considerable wisdom in where you place your weight. As the kids get better at modeling, and as they get better at using the settings in Cura, whatever slicer you're using, there's a place to add extra support. There's a way to have less support.
Mm-hmm.
There's a lot of layers to this, but I mean, even with the video, you can see a horizontal spinner is a pretty easy way to start. We think that's a good start for a student who really is feeling insecure about their abilities. We would provide something like this, and we're happy to share our basic version.
Well, that'd be great
for folks to start something. But I mean, this is not a winning combination. It's a good place to start.
Yep.
There's room to optimize. But
Now your top plate that's on, is that just a piece of plexiglass or Lexan, or is that also 3D printed?
Everything's 3D printed. That's 3D printed. It's just super.
Oh, that's
thin.
3D printed too.
Yeah.
Very nice.
Right. The only thing that is
Now,
not 3D printed is the electronics and the fasteners.
yeah, that's great. And what a great use of 3D printers. I mean, I've seen, as I go around the nation visiting schools, see a lot of 3D printers are just sitting there, not being used for much, because anything useful is a lot of times are too big to print. Or a lot of people just downloading things off Thingiverse, where this gives a really great challenge for kids to 3D print something. And there's a lot of design work has to go into making those motors fit, and making your emergency shut off fit, and making everything so it's going to be the right weight and the right density. It makes a very, very cool competition.
We agree. I think the same rules you have posted for the plastic class are what we have adopted. So just everything has to be 3D printed out of what, PLA or ABS, and
Hmm.
what are the other ones?
PETG
PETG and
PLA plus or something, top
Yeah.
PLA.
right. And
Hmm.
are you still using those materials at the NRC, or are you expanding that at all?
Yeah, I don't know that it has to be 3D printed, but it does have to be those materials. So if they, had a sheet of, PLA they purchased or something like that, they could, cut it out or mill it, instead of 3D printing. But yeah, that's basically the same. I'd have to look and see. There's a list of plastics. We adopted ours from the Spark competition guidelines. So we just kind of follow what they have, and that's kind of the standard, I think, in combat robotics right now, or it was anyway. Not sure after the pandemic how that world has changed. But now, when you guys start with students, how many generally, like how many iterations will a student have to go through design, print, design, print before they come up with something where they're like, hey, this is gonna move and be functional?
It used to be probably 5 or 6, but now I've figured out what I'm looking for more. Like I know what will work or what doesn't work, and we know kind of what you have to have. So as far as printing, usually within 2 or 3, they're good to go because we can check on fusion or whatever. I can check and be like, all right, you need this, this, and this, and it has to be this whole, this has to be this size. We have our sizes
Right.
down. So we've figured that out. So there's not as much wasted printing time in that anymore. It's more than the students figuring out what like 3D print, like how they want to 3D print it. Do they want this infill, this pattern?
Yeah.
You want to change up this
Mhm.
wall thickness, what they want to do.
Hmm.
And we generally like one test print, and then they fix it, we test print it again, and then the third print will be, so the first print is their first go at it. They fix everything. The second print, generally it all will fit together and it works. And then the third print is them actually getting
Optimize,
it to weight. Yeah.
Gotcha. Now, so in your first 2 prints, are you using like a much lighter infill then to just basically have a prototype, or is it full infill on every one?
Nope, we're running like 2.8 millimeter walls and 5% infill just to get it done.
Okay.
See what it is,
Yeah,
because that doesn't really affect anything.
Yeah.
sure. And save you some plastic too, and time, right? That's the other thing. Is you make those. My son, we built a 3-pound, and we 3D printed the entire thing, and it was our spinner was a solid PLA. It took like 2 days to print.
Yeah.
It weighed like 1.5 pounds by itself. So yeah, those are things you learn, like what not to do. So now you mentioned some things you look for that you kind of know, like they're the big mistakes that kids make that right off the bat. So do you have any of those that teachers should look for? Like, hey, if a kid comes to you and they've got this or this, you probably want to tell them to double check it.
Well, the biggest thing, it depends on what motors they buy, but for ours, it's the motors. Like you can see these holes, they're clocked one way or the other because of where the wires come out.
Ah,
That is one thing that they always seem to mess up. And those holes are not all on the same circle. There's
Right.
two different dimensions. So
oh,
Right. They're concentric, but different diameters.
yeah,
I did
And
not know that.
Not
on
obvious.
those particular motors.
You got to have a sharp eye to catch it. But
and then
Huh.
like I know roughly, like I can check the size for the motors. If they're press fitting it, we know what size that needs to be. The biggest thing though to look for, like we kind of let them figure that out because they can find those numbers online. But
Mhm.
like inside wall, you have to have enough room for the motors to actually go in and fit for the wires.
Gotcha.
So assembling it becomes a problem. So like on this one, you can see, they're fairly far apart still in the middle. Like I could put a finger
Yeah.
between. some kids get the inside too small and you can't physically put the motors in.
Oh, yeah.
Sticking out. And I forget off the top of my head what that dimension is, but I have it on we have one that almost touches. So I give that to them as an example and say it has to be this big inside or it won't work.
Gotcha. Sure.
Seemed like year one, it was just figuring out the sizes. Like just can we get the stuff to attach, fit, and will it spin up and fight. In year two, now we're optimizing and looking for where to place weight and how tight you want that fit to be. And really the kids are driving that because they're hooked. They just loved it, and they there's a lot more time, and it's cool for them to be modeling on their own. And kids have their own 3D printers these days, and so it just speaks, you know.
And that's another reason too. We give them 2-inch wheels to start because that gives them like a height constraint off the bat.
Yeah,
sure.
Have to think about 2 inches. While we have kids that use different size ones, but we start with the 2-inch because that forces that height constraint there. Right off the bat, you're stuck to this size.
Yes.
So that helps. Yeah. And then basically 6x6 box. That's
okay.
Some of them are a little bigger, some of them are 5x7, some of them we have some that are 4x4, but if it fits within a 6x6 box to start out, it'll give you a pretty good idea to how to start your design.
That's helpful. That's very helpful. Thank you. Very cool. Any other tips or tricks for new teachers into this?
Just to let everyone know that we're happy to answer questions and help bring people along, and happy to help. So I'd like to see this.
Great. Yeah, thank you both, and Peter, thank you for reaching out about adding this to the NRC. We're very excited about it. I know we started combat many years ago at this point, and a lot of teachers were very nervous about combat robots because of the cost of the large robots and the heavy motors, heavy components, expensive batteries. Well, now with this 1 pound, we really make it very accessible. You could be a homeschool student, family could afford to make one of these robots and enter it. So makes it a lot more accessible to a lot of kids, and with the use of 3D printers, provides a great design challenge as well. So thank you both for your time today. Thank you for sharing your knowledge. We're looking forward to having a bunch of robots at the NRC, and when we post the video, Peter, if you don't mind, I'll share your email address so people can reach out.
Yeah, and another thing too, we print a lot of these on like an Ender. So a cheaper printer, $300 printer, and is just fine. So schools, if they're just starting, they don't have to have a $5,000 3D printer to do it either.
That's awesome. Yeah, it's amazing. I mean, I'm old enough to remember when 3D printers first came out, and Peter, I'm sure you remember. It's like now we have a $300 printer that can print within a 0.5 millimeter of accuracy, where before that was a $50,000 printer. It's unbelievable how that technology has dropped in cost, and that's a great point. I appreciate you sharing that, because Zach, that you don't have to go out and buy this super expensive 3D printer, from that uses powder or some kind of elaborate tank for removing support material. Just a basic 3D printer will do the job for this, and will be just fine for this, especially for this scale.
Absolutely.
So thank you both very much. Thank you for sharing your time. Thank you for being here on your holiday. So enjoy going back to school, and we look forward to seeing you guys at the NRC.
Very good. See you then.